Hello, ladies and gentlemen. It's your friendly neighborhood root beer here, and we're going to be starting another contest from the year 2017. We're going to be starting the written grade 9 contest, so the Friar contest. Okay, so let's take a look here. Friar contest. You can download a copy of the contest by clicking the link in the description below. And standard sort of affair. If you've written a Friar contest before, dates where it's written. Most important thing to keep in mind, your time limit. Every question is worth the same, so don't waste your time on question 4 when you haven't done question 1, because in general, the papers are laid out from easy questions to hard. Calculators are allowed. I've got mine. Hopefully you've got yours if you're going to download a copy of this contest and try it before watching these videos, and I do encourage you guys to practice. Other things to note, light bulb means you just need to put the answer in the box. Short answer questions. You can write a bit more if you want, and then if you're wrong, you can get part marks if you show some work. And then, of course, there are questions with full solution required, so you have to justify everything, state any results that you're using, like the Pythagorean theorem or the tangent chord theorem, something like that. Okay, so as I say, there's 4 questions on the Friar every year. So we're going to start off looking at question number 1, then we'll do 2, 3, 4, but those will be separate videos. Okay. A store sells packages of red pens and packages of blue pens. Red pens are sold only in packs of 6, where blue pens are sold only in packs of 9 pens. Igor bought 5 packages of red pens and 3 packages of blue pens. How many pens did he buy altogether? Okay, so 5 packages of red pens, 6 pens apiece, and then 3 packages of blue pens and 9 pens apiece. We can take a look here, and it's just going to be a quick calculation, even quicker if you've got your calculator. So what is it? Ian bought 5 packs red, which have 6 pens per pack, and then 3 packs blue, and that has 9 pens per pack. Alright, we'll just double check. Igor, I said Ian, didn't I? No, Igor, apparently, in the question. 5 packs red pen, 3 packs blue, 9 and 6, yep. So we'll change it to Igor. Arbitrary change though it may seem. Keep it in line with what they've written. Alright, so the packs will cancel out, and it'll be 5 times 6 pens, so 30 pens, plus packs, 3 times 9, 27 pens. And if you need to, of course, grab your calculator. They're allowed for a reason. So in total, Igor, not Ian, has 57 pens. Okay. So a nice quick way to start it off. And if you just wanted to write 57, of course, that would still get you full marks. But if you wrote something like 56, showing your work can help you get 2 out of 3. You're not going to get 3 out of 3 if you didn't get the right answer, though. Alright, so B part. Robin bought 369 pens. She bought 21 packages of red pens. How many packages of blue pens did she buy? Okay, so this is just sort of a basic algebra question. I'm going to let R equal the number, or no, blue, because it's blue pens she needs. B be the number of blue packages. So she had 369, and we know that that's going to be 21 red packs, which are 6 pens per pack, plus B blue packs, which are 9 pens per pack. Let's double check that we read that right. 369, 21 red pens, 6 pens per red pen pack. And blue packs is what we want. Okay. So 21 times 6, that's 12 6 pens. Plus 9B pens. So if I rearrange, 9B is going to be 369 minus 126. And I could do that in my head if I wanted to, or grab a calculator if I need to. However I want to do it, I get 243 pens. So B is going to be, just divide both sides by 9, and you'll get 27. So I could say something like Robin bought 27 blue packs. Or packages of blue pens, whatever exactly you want to say. Okay. So that's Igor and Robin dealt with. Okay, C part. Explain why it's not... we've got another person now. Explain why it's not possible for Susan to buy exactly 31 pens. Okay. What are we to do? So we've got to explain, we've got to justify. And the sort of what we need to justify is the statement, Susan cannot buy 31 pens. Okay? So either we need to use a piece of information that we've already got about the pens, and we don't really have a whole lot. A and B, we've just been doing calculations. Or we might do what's called a proof by contradiction. Let's say, for argument's sake, Susan could get 31 pens. You know, she buys this many red packs, this many blue packs, and you know, we know how to add them up. We know how to do the calculation. So then we say, well, why won't this calculation work? Okay, and then, you know, if we get to a point where, you know, the number of red pen packages had to be negative, well, of course, that's silly. And the only way to arrive there is for our initial assumption that she could buy 31 pens to be wrong. That's proof by contradiction. You assume what you're trying to show is false is true, and then you show that that leads to something silly, something crazy, like, you know, 1 has to be less than negative 5, things like that. Okay, so that's what I'm going to do. So I'll say, suppose it were possible. Susan buys R red packs, B blue packs, and if you want to, you can use a different letter than B and R. If you're worried about the marker reading and mistaking your B from the last question to be this B here, but most of the markers won't make that sort of a mistake. So she buys R red packs and B blue packs and gets 31 pens. How do we calculate that? That's 6 pens in each red pack and 9 pens in each blue pack. Okay? So we're good at making this calculation here. Now, what have we got here? Well, I need to show this equation can't be satisfied. What do you mean it can't be satisfied? Just let B be 0 and let R be 31 over 6. Well, there's some assumptions. You can't buy half a pack or root 3 of a pack. You have to buy whole packs. And as I said before, you can't buy negative packs. She could buy 0 blue packs, for example, but she can't buy negative 1 blue packs. That's just crazy. So we have some assumptions, and we should probably write them out. R and B are non-negative integers. Now, we really just need R and B to have to be integers for this to work out, and you'll see in a second why. But you do have to write that, because if R and B are allowed to just be anything, you can satisfy this. Okay? If she buys 31 over 6 red packs, yeah, she can satisfy this equation. She'll get 31 pens. The point is you can't buy a sixth of a pack, for example. Okay? So what I'm going to do here is I notice, oh, we got 6 and 9. I'm going to take out a factor of 3. Now this guy in here is an integer. Why is he an integer? Because R and B are integers, 2 and 3 are integers. You multiply integers, you get an integer. You add integers, you get integers. Don't have to specify it, but I do have to acknowledge it. We've got an integer. So 31 must be a multiple of 3. Right? We rearranged the right-hand side, and that's the definition of being a multiple of 3. 3 times some integer is always a multiple of 3. But this is impossible. We know that 31 is not a multiple of 3. 30 is the closest multiple of 3. So how did we show that 31 is a multiple of 3 when it clearly isn't? By assuming something that was impossible in the first place. So our assumption that Susan can get 31 pens must be wrong. Because none of the math in here was wrong. If you start with this statement, if you say this is true, you can rearrange and get this statement, which is clearly false. So what must be wrong? This statement must here must be false. We must have assumed something false to get a contradiction here. So if our assumption that Susan can get 31 pens is wrong, that must mean the opposite of that must be true. So Susan can't purchase 31 pens. It is impossible. If it were possible, 31 would be a multiple of 3. We know it isn't. Okay, and so there we've written up enough for C. We stated very clearly. Let's assume we could do it. She'll buy R pens, blue and R red packs, B blue packs. We're not making any assumptions on them other than the obvious. They have to be integers. You can't buy half a pack. You can't buy a billionth of a pack. We set up the equation just like we've been trained to do with the Igor and Robin questions, stuff that we were introduced to, and we got a ridiculous statement out. That's exactly how proof by contradiction works. Okay, so that's question 1 on the 2017 Fryer paper. Join me in the next video for question number 2, and if you haven't already, take a look at the contest in the meantime. Try question 2, 3, 4 out for yourself and see what you can do. Okay, but until then, have yourselves a wonderful day, and I'll see you later.